These are your 5-4 notes. We're going to graph polynomial functions now. So the previous lesson involved figuring out end behavior, determining the number of real zeros, and all of the wonderful where it starts and stops, if it's up and down or opposite, where it starts, if they're both going down or if they're one up, one down. So the previous lessons kind of led us into this. So now we're actually going to graph these power functions. So we're going to get as much information as we possibly can before we graph. So a couple of those things, total number of zeros. Remember, the total number of zeros is the degree. So if you have a degree 5 polynomial, there's going to be 5 total zeros. That's real and imaginary. The y-intercept, that is your, when you plug 0 in for x, it ends up being your constant value in the function. And then we have the end behavior. Now, I don't need the formal end behavior here. What I'm looking for is that if they're both up, if they both start up, if they both go down, if you got one up, one down, or down and then up. So reading the graph from left to right, where does it start, where does it end? And that gives us a good idea about the graph. And then the last thing is the number of direction changes. And the number of direction changes is the degree, take away 1. So if you have a degree 4, it's going to change directions 3 times. That's pretty much everything that we can do without having to use the graphing calculator. And so the next part is to calculate and plot zeros. So we're going to calculate the zeros using the graphing calculator. And if you remember, the zeros are the x-intercepts of the graph. So we're going to use the graphing calculator for that. We're going to calculate the relative minimas and maximas. And so that's using the graphing calculator again. And I'm going to explain and define what relative minima and relative maxima means on the next slide. And then the rest of the graph we're going to get using the table of values. So we'll use just a random table of values. They're not always nice values, but we'll get enough to put this picture together. So a relative maxima sounds like maximum, and it really is sort of the same thing as a maximum value. The reason they call it a relative maximum or maxima is just because it's truly not the biggest point on the graph. It's just relative to the points around it, it's the highest point. So it's the maximum point in relation to the points around it in that given area. And a relative minima is the lowest point in a given area in regards to the points around it. So if you look at the graph here, this graph actually has 2 relative maximas located with the red dots, and then the 2 relative minimas are the green dots. This graph actually doesn't have a true minimum or maximum because this never ever ends. And so if it goes up forever and ever and ever, it will never maximize. And also it goes down forever and ever and ever. So there's really not a true minimum value because the numbers keep going, approaching negative infinity and then positive infinity as well. So we call those relative maximas and minimas. So we're going to try this. It states everything we need there. We're going to do everything we possibly can. The one thing I did not mention on the last screen was list how many imaginary zeros there are. So to find out the number of imaginary zeros is your total number of zeros, take away the real amount. So you remember, if I have a degree 4, but none of them hit the x-axis, that means all of them were imaginary. So that would be total 4 minus 0, that sort of thing. So we'll go through that, but you really can't do that until you see the graph and how many x-intercepts there are. So looking at this equation, I notice it's degree 3. Okay, so my degree is 3. So the total number of zeros is 3. I know that my number changes, direction changes, is going to be 2. So this graph is going to change direction twice because 3 minus 1 is 2. My y-intercept, I'm looking at it here. If I plug 0 in for the x values, those first 2 terms will go away. And so my y-intercept is 5. And knowing that my degree is 3 and it's odd, and that my lead coefficient is a +1, that tells me odd means they're going to go in an opposite direction, and a positive lead tells me it's going to end up. So I know that this graph is going to start somewhere down here. It's going to end somewhere down over here. I'm going to hit 5 on the y-axis. And that's pretty much all I know. I know it's going to curve twice in this process, so I can start getting a plan as to what's going to happen here. So now we bring in the graphing calculator. Now I know you don't have one at home, but we'll practice this when we get to class as well. So when I pull up my graphing calculator, I'm going to put in that equation, y equals x cubed minus 4x squared oops, I forgot to hit arrow over. All right, let's try that again. So I'm going to x cubed. I have to hit arrow to go back down to put my minus 4x squared, arrow over so that I can put +5. So make sure that the equation's in there correct. I'm going to hit graph to see it and just kind of verify my stuff. Yep, it starts down, ends up. That's good. I can see where it crosses the y-axis at 5. And then I can also see that I have a minimum and a maximum value. So I'll have to calculate 2 values, minimum and maximum. And then I'll also have to calculate these 3 zeros. So here's a 0, here's a 0, here's a 0, which tells me I have 3 real zeros. Okay, and then if I have 3 real zeros and I had 3 total zeros, that means I have 0 imaginary zeros. So just mentioning that tells me you know what you're talking about. So let's do the zeros first. To calculate zeros, I'm going to hit second trace for calculate. And I'm going to calculate, let me just delete those really quick. Maybe. And so I'm going to hit 0, number 2. Okay, why is that not going away? Go away. There you go, sorry about that. Oh, come on. Give me 1 second here. All right, sorry about that. Okay, so I'm getting mad at the board here. So when I want to calculate 0, just let me go through that one more time. Second trace to calculate. I'm going to calculate the 0, choice 2. It's going to ask me 3 questions. Left boundary, we're going to go before the 0, which would be below the graph. So I want to put my cursor right below the x-axis and below the graph. Remember, from left to right, hit enter. Right boundary is after the 0 occurred, so above it. Hit enter, and it's asking me to guess, so I'll try to put it right on top of it. Hit enter, and I get -1, 0. Now, because it's a whole number, you probably could have just told me that. So my first 0 is -1. These are your x-intercepts. We're going to do that again. Second trace, I'm going to calculate the 0, so I'm going to pick 2, and now I'm going to calculate the next 0. So the left boundary is before the 0, so this time before the 0 is above the x-axis. My right boundary this time is below the x-axis, hit enter, and then try to guess, put it on top of it, hit enter, and it's 1.4. So I have another 0 at positive 1.4, and my third 0, hit second, trace, 0, and I'm going to get that third 0 there. My left boundary is below, enter. My right boundary is above that 0, enter, and then if you want to guess and try to put it on top of it, enter. So they ask you 3 questions. This is 3.6. So they weren't pretty, but that's okay. So now I can put those 3 points on my graph. So I know on this graph, I hit the graph at -1, at about 1.5-ish, 1.4, and at 3.6. All right, so that tells me a little bit of a story. The next major point that I need to know these minimum and maximums. So I need to know where it peaks and where it valleys. Now, it could possibly peak at 5. I'm just going to make sure that I calculate it, because what if it's a little bit above 5? What if it's a little bit, is it at 0.5? Is it at -0.5 and something else? So I'm going to hit second, trace, and since it's a peak, I'm going to do 4. That's my maximum. So you calculate a maximum just like you normally would a regular maximum. It's the same thing. So I have to do a left boundary, so I have to be before the peak, enter, after the peak, enter, and if you want to, on the peak, enter. Same 3 questions. And so this is telling me 2.053 e to the -5, which is really 10 times that to the -6, so it's 10 times the power -0.00000205. It's really 0. It's a really small number. So my x-coordinate is given in scientific notation. Sometimes when it means 0, it just calculates that way. So 0.5 is my relative maxima. So I just want to make note of that on my paper, that my relative maxima is at 5. Remember, your maximum or minimum value is the y-coordinate. And so now we're going to do the minimum, second, trace, to calculate my minimum, which is 3. And I hit the left boundary now is before the minimum. Enter. The right boundary is after. Hit enter, and guess is on. Enter. So where do we bottom out? At 2.7 and -4.5. Now you might want to put that in an actual table of values because it's a nice table to have, but we're going to, so my relative max was at 0.5, but 5 is the maximum value. And then my relative minimum was at 2.7-ish and -4.5. Okay, and so what we're going to do is we're going to go ahead and plot those. So I have my relative max is already there. It's my y-intercept. My relative minimum, 2.7 and -4.5, is right about here. The rest of the points I can get from my table of values, but I think I actually closed my, my graph out. So what I really want to know is how do these points play into it, and how do these points play into it? I know when it crosses the x-axis, but I want to know how did it get to the y-axis. So I would be looking at these ordered pairs to the left and to the right, and so that we can actually see how this all comes together. The points in between we really don't need to know. So when you look at the table of values, you're kind of looking to say, how did I enter that first 0, and how do I exit the last 0? All right, next problem here, same idea. I'm just going to gather all the information, and then we'll be ready to graph this in class, because it's kind of difficult when you don't have the graphing calculator at home. So first of all, we have a total number of zeros. Total zeros is equal to 4. Okay, my degree is, it's an even degree. It's a positive lead. So what that tells me is that they're both going to be up or they're both going to be down. And because it's a positive lead, we're going to start up here somewhere and end up here somewhere. My y-intercept is 12. So 0, 12 I can put on the graph. And I really don't know imaginary zeros. I have my end behavior, direction changes. Total direction changes. This graph is going to change direction 3 times because it's the degree minus 1. So we can't really do the zeros, the values of the real zeros, the maximum minimums, and we can't really do the imaginary zeros until we see the graph. Okay, so we're all set up for tomorrow. What I want you guys to do today for the lesson summary, I believe I give you a freebie here, and then I just want you to do the same thing on this one. Tell me everything you can about the function without graphing it. So you're going to do what we just did on the last slide, all by yourself, get all of that information, and then we'll go from there. All right, good luck.